Hi, how's everybody doing? So, do you guys have, maybe start with homework questions? Have you guys taken a look at 4.7, 4.8, or 4.9 and have any questions from there? Paulo.
Can you do 25 on 4.7?
Yeah. Let's... All right. Which problem? 25, you said?
Yes, please.
Okay. Where is my... All right. It says, find the dimensions of the rectangle of largest area that can be inscribed in an equilateral triangle of side L if one side of the rectangle lies on the base of the triangle. So I'll start by just trying to sketch out a little picture. So here's my equilateral triangle, right? And I know somewhere in here I have my rectangle, right? Paul, does this feel okay?
Yeah, I got that.
Okay. Well, I know I have L and W because I care about the area of that rectangle, right? That's what we're going to try to maximize. So what I want to do here is I want to try to first resolve this into a single variable, right? L or W. So let's think here for a moment. So if I call those X and X, well, no, this should just be L minus L over 2, right? So I can say then that tangent of 60 degrees is going to equal W over L minus L over 2. Does that feel okay there?
Yeah.
Okay. Now, tangent of 60 is Huh? Root 3. Sounds right. And I'm going to simplify that complex fraction. Okay with that? And so if I multiply both sides by L minus L, and then divide by 2, that's W. So far, so good? Okay. I'm going to just clean that up a little bit before I differentiate. So I'm going to pull the root 3 over 2 out to the front and then distribute the little, or the script L through. Okay, so if I take the derivative then, I'd get that. And if I set that equal to 0, I can apply the zero product property and say that L should be cap L over 2. And if I think about the graph of this, where the x-axis is lowercase l and the y-axis is the derivative a prime of L, and this spot is like L over 2. If I come from a value that's less than L over 2, L minus 2 times L over 2 should be positive. And if I pick a value bigger than L over 2, 2 times L over 2 should be bigger than L, so that should be negative. So if we go from increasing to decreasing, that's a maximum. So I'm quite confident that that's my max. So to find that maximum volume, then I'm going to just do A of cap L over 2. And let's see if I simplify that down. I would get L squared root 3 over 8 as my area. Let's go see how badly I messed that up. Hopefully not very, right?
I think you got L's right.
Yeah, well, who knows how the back of the book represented the answer. But let's take a look here. So it's 25, is that what this is? Let's see. Yeah. Okay, so that was set up correctly. L of 2 is correct. The maximum occurs when, well, I don't care about that. It doesn't, oh, find the dimensions. I'm so dumb. It didn't ask for the maximum volume, it wanted the dimensions. No wonder I can't find the answer. Okay. So L over 2 is 1, and then the width is just going to be root 3 times L minus L over 2 over 2. So that's my width then. I didn't need to do any of that. The graph I needed to show that it was make sure it was a maximum, but the to find the area, it didn't ask for the area. It asked for the dimensions that would maximize the area. I misread the question. But Paulo, that's the gist of it. Did that feel okay?
Where you get root 3, break that last part that you just did.
So I just plugged my answer for script L into that.
Oh, yeah.
So that's all I did. Because I already had the expression for W in terms of L, so I just plugged it in and simplified down. Is that?
Yeah.
Sure. Other questions from homeworks or whatnots? Yeah, Ryan. Same section? Okay. Find correct to 2 decimal points the coordinates of the point on the curve y equals sine x that is closest to the point 2, 4. What do you notice is about this problem right away? If it wants 2 decimal places and has this little guy here, probably need to use my graphing calculator to solve this. It may not be something that's resolvable by hand. But let's sketch a little picture of kind of what's going on. So we have the graph of sine x so just make that like pi over 2. Well, I didn't do that right at all, huh? Good counting there, genius. All right, so make that pi over 2. I'll make that pi, 3 pi over 2, and then 2 pi. And that's like minus pi over 2, and that's minus pi. So that's like my sine function. And then 4, 2 is going to be like somewhere over here, right? A little bit after pi. So far, so good. So I want like whatever that distance is, right? That's what we're looking for. That kind of minimizes that. So this point here, I'm going to call x comma y of x, or really x comma sine x. So I can say then my distance is going to be the square root of x minus 4 squared minus 2 minus sine x squared. Feel so far so good, right? Okay. So if I take the derivative of this, notice that this is a function just in terms of x. That's why I did this instead of xy, resolved it to a single variable. So we'll take the derivative. And I had to do like a couple of chain rules in there to get that derivative, right? But if I'm just doing this on my calculator, which is kind of what it suggested, this is what I would have done. I wouldn't bother to even do the derivative by hand. So I'm just going to do square root x minus 4 squared minus 2 sine, or I'm sorry, minus 2 sine minus whatever. You know what I can't speak. Right, so I have my function. And I don't really want to bother graphing that. But what I want to graph is its derivative. So to graph the derivative of this function, I'm going to do math and then n derive. Make it with respect to x. And I'll do that on y1. So I'll press vars and then go over to the y vars and then function y1 of x equals x. So that's just going to graph the derivative of the function y1 for me. And I guess I'll just go from 0 to 2 pi or something. Because although the answer to x could be any real number, I know it's going to be around where 4 is, right? It's not going to be too far from there. So that ought to cover it. And I'll go like -2 to 2 just so we get a decent picture. And I guess as long as I'm going through all this trouble, I'm going to plot the point 4, 2 also, just so I have it. Got all this mumbo jumbo in here. So I'll just go ahead and make the point 4, 2. Okay. I didn't get it's all the way up there, but oh, yeah, that makes sense. All right. We got to do better than that. Let's just make that -10 to 10. So here's the graph of the derivative. Is that right? Did I type that in right? Oh, I get it. Okay. So when I go and I look at this doesn't look very nice, right? I think because the negatives and the square root are just like really making a mess of this thing. That's unfortunate that that didn't come out better. That would have made life a lot simpler. All right. Yes, go ahead. So we'll continue on. I guess we'll do this a little bit more by hand until we can get to a spot where it makes it a little bit easier. So I'm going to go and take this 1/2 and distribute it through to cancel that stuff out. So I have that, right? That should be plus. Sorry. So if I set this equal to 0, I know a fraction is equal to 0 whenever its numerator is equal to 0. Is that okay? So let's just do that. So I'll graph that. I know why it's being so strange. Gosh dang it. That's why. So dumb. Okay. I knew I should have looked at that a little harder. Ruh-roh, Raggy. It's not what should have happened there. What happened? I must have made some kind of typo mistake. I'm going to go back, though, and do see if now that I have the radian mode back on, I can't believe I forgot to check that, if doing this is going to give me a more sensible looking graph. Because this is really what I wanted. You got pretty much the same thing? Well, this I'm liking. Oh, it's still coming out. Why is it doing that? It's so strange. Did I do something wrong here? So it did that. Oh my good googly moogly. I am so dumb. Who sees why I'm dumb? It's like the dumbest thing you could possibly do. Look at the very first thing I wrote down, D equals.
It's supposed to be sin x minus 2.
Yes, it's supposed to be sin x minus 2. Great googly moogly. Don't be shy. If you think I did something dumb, like at least ask, man. Like maybe I didn't do something dumb, but if I did, like, whew, Billy, that's a big catch. All right, so we do that, and now we're getting stuff. Look, it's crossing. Oops. I don't know what I'm drawing anymore. That still didn't feel like it did much. Okay. All right, so let me just. Oh, that gave me. Well, that was weird. Okay. All right, so let's fix this one then. Oops. Oh, yeah. And then this will be minus then, right? See what I get with that. All right, let's fix some of this stuff here. All right.
Trans is not much easier.
What happened now? I wish this was just easier to read. Okay. Okay. Okay, more. Sure.
And I told him, here. Getting so close, Mr. Cole. I'm in a second, I feel the same way. And I test sister.
Oh my, I can't look at, I am so sorry, guys. Look at this. Look.
Oh.
This needs to be x minus 4. And look there, now we got one. That's what I've been looking for. Yeah, just eventually I'll get rid of all the mistakes and we can find it. So there we go, 4.53. But it says it's not that.
Oh, are you serious? Well, that's his question. He saw me skip down. Whoa.
sure.
No extra points for life either.
So this should be my minimum. Why is that not the right number? Yeah.
You see where the 4 minus x squared minus
Yeah. Why? Boy, oh boy. So that's going to be a plus there as well. All right. All right, let's see. Did it do it? There we go. There, finally. Jeez, so Pete's. All right. So let's bang that. Well, come on, guys. That's like, I didn't remember the distance. I remember done the distance formula wrong. It's not like you're, like, that's a great, thank you for paying enough attention, but like, all right. So this is the graph of the derivative, right? So I see zeros here, here, and here, correct? The only two I have to check is this one and this one, correct? Because this one can't be a minimum because it's going from increasing to decreasing. That's a maximum, right? Because it asks for the shortest distance or closest point or whatever. So remind again that the point we're looking for is that point 4.2. So it's like, yeah, right there. So which one will I need to be? Well, let's just check here. So zeros, I'm pretty sure I know why I'm going to discard that one over there, but so 265 is one of them. And I need to catch that other one over there. And 61284. I thought that would be more obvious. So those are my potential minima. So if I then just check the distance of each of these and see which one is going to be less, I guess I'll just do them both to 2 decimal points. I'll just check. So the easiest way to do that would be my distance function is in y1. So I'll just do y1 of 2.65. And then y1 of 6.18. So that's the one that I want. Ryan, apologize for making an absolute mess out of this thing. If I could write down things correctly, I feel like we would have been done 10 minutes ago, but I'm sure we've all been there, right? Where it's like, I can't write anything down on this problem correctly for some reason. That was me right here. It's probably because I had the book open. Before, when I didn't have the answer book open, when I did Paulo's, I did it, everything was fine. I just solved for the wrong thing, but like all the work was right. Here I have the answers open, and like I can't make heads or tails out of what's going. Anyways, ay. I hesitate to ask, but who's next? Because my performance has been not real impressive. I apologize. Happens. 26.
It's like 25. It's just there's more gifts.
That's famous last words, right? All right. The area of the largest trapezoid that can be inscribed in a circle of radius 1, whose base is a diameter of the circle. Okay. So I'll just like, here's a circle. Let's say that's the center. So far, so good. Okay. So do you remember the area for the area formula for a trapezoid?
Base 1 plus base 2 over 2.
Yeah. Yep. So the height so I want to probably resolve this all down into like in terms of like x's and y's, I suspect. So I'm just going to like embed this thing onto the xy axis. Maybe I should do that in a different color. So if I do that, you know, those points are just like some generic xy's, or really, I guess I could do that. That's like -1, that's +1, right? So I know that, say, if I call this guy base 2, what is that going to have to equal? 2. Is everybody good with y base 2 is 2? If I call this base 1, base 1 is 2x. Everybody's okay there? Well, how far is it from -2 to +2 on the number line? 4 units, right? 2 back to 0, and then 2 from 0 to 2. Same idea here. We're on the same horizontal line, y equals, right? And we're going x to the middle, to the y-axis, and then x more to the other point. Is that?
Yeah.
Or you could do the distance formula. That's a lot of overkill. You'll get 2x also. Woof, though. You know. So there's my bases. I think the tricky part's going to be the height. So the good news is that like this distance is the height here, right? It's like 0y is that point, correct? That's the same y as right here. Everybody's okay there? And how can I rewrite that y in terms of x? Well, what's the equation for the radius of a circle with, or the equation for a circle with radius 1? centered at the origin. X squared plus y squared is equal to 1. So I know that y is going to be the square root of 1 minus x squared. And I can drop the plus or minus because I'm on the positive part of the y-axis also, right? So this is my h. And now I think I have everything I need. So I have this in terms of x. Oops, I guess I put it the other way. Is that what they did? Yeah, good enough. All right. So they did a bunch of funny business to like simplify this to make it easier. I don't want to do that because I don't like the funny business they're doing. But we'll do that at least. So far, so good. Okay. If I do the derivative, that's going to be a product rule. And then to do the derivative of the 1 minus x squared to the 1/2 is a chain rule. So I can do that. If I make a common denominator, I'm going to have that. And we'll set that equal to 0. I know a fraction is equal to 0 only when its numerator is equal to 0. To solve this by hand, I'm going to add that non-radical stuff to the other side. So when I square both sides, I don't have to FOIL anything. And I will FOIL that piece out. And then distribute my x squared through. And then I'll get everything onto one side. Okay. And I guess I should try to solve this. But I guess I could do some polynomial division to solve this if I'm trying to do by hand. By inspection, I know that if there are rational zeros, they're either going to be plus or minus 1. Quick check, I can tell positive 1 doesn't give me 0 here, right? So let's try a negative 1. So that worked. So this thing has to factor x plus 1 times x cubed plus x squared plus x minus 1. And if I try this one, neither work. I don't get any zeros from that. So I just have x equals -1 as my only solution, because that other piece isn't factorable over the rationals. And I'm just going to cross my fingers and hope that there's no imaginary solution to it. Well, I guess it doesn't make, or irrational solution to it. There could be irrational ones, but I'm just going to cross my fingers here, I think. If I plug a value less than -1 in, I would get negative, and then I have 3 negatives and only 1 positive, so I'll get a negative over there as long as the value is bigger than 1, like -2 or something. So that's going from positive, and then if I plug something bigger than -1 in here, that'll be positive, and these things will be, like if I put 1 in, that's clearly positive over there. So we're going from decreasing to increasing. So that means this should be at a minimum. Oh. That doesn't, oh, that can't possibly, I made a mistake somewhere again. God dag nabbit. Where would it have been? $100 for who sees it first. I'm just kidding. I don't have $100. Okay. So I did that. It's good. And then that's the derivative of that times that. Okay. And that's there. And this is the derivative of this. Okay. The 2's can cancel. I took the negative. That's my numerator. That's my denominator. That all looks good. Make a common denominator. So that's, oh, I see. This is just to the first. That's it. That's enormously helpful. So get rid of all this junk down below. All right, rock and roll. That simplifies the algebra enormously. You guys aren't as excited as I am. Why not? So instead of having a degree 4 polynomial to deal with, it's degree 2. Wow, that's a lot better. We'll quadratic formula that. So 4 times 2 times -1 is -8. So that's going to be 9. Square root of 9 is 3. So there we go. That's better. All right. And then I first derivative test these guys. Well, right away, hold on. Right away, look at our picture. Look at our picture. Can x be -1? Right? If it is, what do we have? It's like a straight line, right? There's no area to be had. So immediately I can just discard that one. Woo! I don't even have to check it. Common sensed it. Boom. So if I do 1/2, if I pick something that's bigger than 1/2, I'm going to have yuck. I don't know. Let's just. Well, I need to remember that my domain has to be between -1 and +1, right? So I got to make sure I'm not checking outside of that, or I might get some nonsense mumbo jumbos. But I know I don't have to bother checking the endpoints because of the nature of the problem. Like you're just going to be a straight. You're going to get area 0. Woo! But that should work, indicating that this is a max. So if x is 1/2, what are my dimensions then? I go back to here. So base 2 should be 1. And then the height should be so those would be my dimensions. If I can get my work straight, my goodness, I have the right idea every time. It's like, I'm doing it. I made a mistake somewhere. Now it's a hunting through a haystack looking for that needle of a mistake. You're welcome. All right. Should we talk about exam-specific stuff here? All right. So you guys said part 5 sounded the scariest, the application pieces. Okay. So these are like the topics for the questions in part 5. So there's 5 different questions. That's 20 total points in section 5 to choose from. So you'll have a related rates question, a position, velocity, acceleration question using antiderivatives, finding the place on the function where the derivative takes the average rate of change, finding the place, the location, the xy on the derivative where it takes on the average rate of change. Inflection point intervals, a concave up, concave down, and then optimization. So that's what you should, those are the types of questions. So in part 4, you should be able to show continuity in a piecewise function. So you should be able to show differentiability, or at least give the intervals where a function is differentiable. If I give you the function, you have an IVT question, an MVT question, and then you should be able to find the places where the graph, or where the derivative doesn't exist, or where the function is not differentiable, looking at the graph of the function. Part 3 is just doing derivatives, right? So you only have one problem that has to include multiple derivative rules. So your problems will include quotient, product, chain, implicit differentiation, double chains. 1, 2, 3, 4, 5, 6, 7. There's 7 of those problems. I guess I could. Yes, Selena?
Are we done now? Let's use hospitals rule.
L'Hopital. Hold on while I throw up in my mouth after you ask me that. Yes, of course. So in part 2, those are the derivative one, or the limit ones. 1, 2, 3, 4, 5, 6, 7 of those. You're going to have regulars. You're going to have L'Hopitals. You'll have the definition of a derivative. You'll have from a graph. But you should be able to do that kind of stuff. So in part 1, there's 10 multiple choices. Again, there were 2 points a pop, right? So you don't have to do all 10 of them. Although I think it'd be silly not to circle some, do 5. Okay, I think I got 5, and then just I'm going to circle some random ones, not bother turning them blank, because maybe I pick up a free 2 points that I might need just on accident, right? They all had 5 options. If I just randomly choose 5 of them, I should get one of those for free. Just if I'm lucky, if I'm reasonably lucky, the expectation would be I could pick up one for free. That ain't bad. So in general, these, so we have basically you should expect to see 2 multiple choice questions from each kind of test. Not the test topics, right?
Oh, not
not copied and pasted. But I would say, in general, the questions that I've written for the exam are easier than the average test question would have been,
That's good. That's good.
because you have so much more to worry about, right? Like, I tried to pick things that like are not like computational nightmares,
Okay.
like that don't get sticky, right? The multiple choice stuff that doesn't like, oh, this is like a full blown, like I just have to grind like some huge problem to answer this stupid multiple choice question. It's not like a conceptual know it or I don't kind of question. I tried to pick things that don't require tons and tons of time, that are relatively straightforward. So again, like from the first test, things that you should know. We have your limit stuff, right? Continuity. Should know the limit definition of an asymptote, whether it's vertical or horizontal.
Yeah.
Right? From test 2, like product rule, chain rule, continuity or differentiability, specifically for piecewise functions, right? Because those two things are linked together. What can you say about a function that's differentiable for free? It's continuous. Can you say the same about a continuous function? No. Right? What's your canonical counterexample? The absolute value function, right? Continuous over its entire domain, not differentiable because it has a corner. What are the other two things that can cause a function to be not differentiable? Vertical tangent and a discontinuity. Yeah. So whether that's an asymptote or a jump or a hole or whatever, discontinuity in general, but yes. And I would say like local linearization. I can't remember if that was a test 2 or 3 topic. I think that's a 3. So on 3, you have local linearization. I think chain rule was actually test 3. I think test 2 was just product and quotients. Should be able to deal with like derivatives of an inverse function, not like the trig inverses per se, but like where f of g of x is equal to x, like those kind of problems. I think we saw a bunch of those in test 3. From test 4, you should be able to deal with the local extrema, like the local mins and maxes, using a derivative. Whether I gave you the derivative as a graph or as a function. And then from the last 3 sections here, it's basically antiderivative stuff. So no Euler's method on the exam, I'll tell you. Okay. That's kind of me outlining the exam topics in a nutshell. Does that help like focus your studying as to like what kind of stuff you really have to be up with? Again, differentiability, continuity, got to understand those topics really, really well. Like what those mean, how to show them, when they would fail or not fail, how to tell if they failed or not failed, using different ways, whether it's from a table or a graph or a function. You should be able to know how to check for those things. You know what I'm saying? What to look for. You should be able to do limits, derivatives, antiderivatives. Should know how to check for mins and maxes and inflection points and intervals increasing, decreasing, concave up, concave down. You should know the 3 big value theorems: extreme value theorem, intermediate value theorem, and mean value theorem, and like how to use them. Right? Specifically, you need to be able to you need to know the conditions that you need to have to use those things, so that if I ask you to show something, you can check the conditions, because that's for sure going to be points. Like if you don't check continuity or differentiability or whatever you might need to before you apply the theorem, you apply the theorem, get the conclusion that you needed, but you didn't check for the hypothesis, you lose points on that. You know what I mean? I don't know, does that help kind of outline what to expect here? I gave you the number of questions for each part, you know, how much each question in a part is worth. You have an outline of like the kind of topics and the kind of problems that you'll see in there. Maybe next time I'll have some like specific examples that I've written up, but I didn't have a chance to get to that today. But if you guys have specific stuff you want to ask about, I'm certainly willing, you know, like ready to do that right now. Paulo?
Do it piecewise next class.
I mean, we can do it piecewise right now. All right, so let's say this is our piecewise function. And let's say we want to check continuity. So I'd say f is continuous from negative infinity to negative 1 because something. F is continuous at x equals negative 1 because something else. And then I want to say f is continuous from negative 1 to positive infinity because third thing. All right, so that's my general setup. If I'm showing a function is continuous, I need to show, and it's piecewise, I need to show each piece is continuous, and then the boundary has continuity. How do I show that f is continuous from negative infinity to negative 1? Yep. Good enough. Maybe I'll say okay. How do I show that f is continuous from negative 1 to positive infinity? Same thing. How about at negative 1? So I need to show that the left-hand limit is equal to the right-hand limit, which is equal to the function. So the left-hand limit is just going to be that, right? So I get negative 7. The right-hand limit, I think I screwed this up, but that's okay. I get is 8. And guess what I can show right now? It's not continuous. But that's the general, Paula, what you do to check for continuity. Now, if it also asked about differentiability, I'm done also, right? How do I know this is not differentiable? It's got a discontinuity in it, right? Easy enough. Let's just take a guess we should do that. Makes more sense. So if I want to say this is differentiable, first I have to check continuity. Why is it continuous from negative infinity to -1? Oops, not -1, +1. I'm still in the previous problem. And here I have the limit as x approaches 1 from the left, and the limit as x approaches 1 from the right, and then f of 1. Well, this is just 2 times 1, right? Ugh. And this is, I screwed it up again, guys. I'm just going to tack a +1 onto that. So got it, right? And then f is continuous on here, again, because it's polynomial. Okay, so then I take the derivative. So the derivative of 2x is 2. And I have to do a strict inequality here. The derivative of x squared is 2x. Well, I know that this is continuous from negative infinity to 1 because it's polynomial. And I know it's continuous from 1 to positive infinity because it's polynomial. And then it's continuous at x equals 1 because the limit as x approaches 1 from the left equals the limit as x approaches 1 from the right equals the limit at 1. So there we go. Follows that?
Yep.
Okay. So again, like if you're asking, it depends if you're asking about a point or the whole domain. If it's the whole domain, you have to check more than just the inner or the link, the boundary between the pieces, right? And if there's 2 pieces or 3 pieces or 4 pieces, it's really the same exact process, right? Is that a good jogger?